And just so you know, we will be recording this webinar as a resource for the Portland Metro STEM Partnership. So always want to say that outright.
And those links is the idea capture tool. You might be used to that by now, but if we do.
You are mute, Brett.
I was just mentioning that the idea capture tool, we're using it for attendance, and it's also just a chance for you to let each other.
I think Bradford's internet dropped out. So we're using the idea capture tool there. And it's just a place where we can take attendance and also so you get a chance to check in with others around you. Specifically on number 4 there, the idea for number 4 was that you are just trying to get some feedback or trying to hear what other people are doing for anything related to what you're teaching. So specifically, like our question was, if you're transitioning to maybe a hybrid model, who knows what different districts are doing? Can you use that? Maybe that's something that you want feedback on. Bradford, you cut out there for a second, but you didn't lose the screen share. So
Yeah, good, thanks. Sorry about that.
And I'll post in the chat one more time here the links for today. You'll see that several times if you're already in. The first is to the activities for the prioritized learning targets that are remaining, and then the agenda for today, and then that idea capture tool. And as Bradford said earlier, we will be using the idea capture tool for attendance. So if you just want to scroll down and find a place to put your name there.
And once you finish, if you want to read other people's questions that's them asking for feedback. So if you have some feedback to give them, that's probably appreciated. Probably about just 60 seconds from starting up fully.
Are you in class? Sorry about that.
No problem. Welcome. We are probably just 20 seconds from starting, but I'll just try to say everything quick from the top. If you could, we'll put some links back up, maybe paste those one last time. And then in the idea capture tool, please do make sure you click here to add your name. We're using that for the attendance. And then with this last couple 10 seconds, if you want to take a peek at just where other people are at. People are always kind of curious, and I just put it out there that we've just seen it too often that you feel pressured by that or something like that, and that I don't think people are really in different contexts and situations. So with that, also number 4 is a request from people to get a little bit of feedback. So if you have time to look at that. But I think we'll get started, and we're not going to dive right in. So we got a couple more things to say, but we'll get going. Just a quick introductions. Bradford Hill, science and engineering teacher at Mountainside High School.
And I'm Matt McCollum. I teach science, physics, and IB physics at Mountainside as well. And
as so often is the case with these webinars, really the 2 big goals is that overview. It's a little different because we're not called this a unit, and we'll say more about that, but really the overview of the prioritized remaining learning targets. And then secondly, to preserve that structure though to dive into one of the activities. And today will be a little different in that we'll open it up to any activity, and we'll open up the rooms and you'll be able to choose which activity to dive into. And so just, a couple notes that we do, I think want to just acknowledge and let you know that you have this, what's resources are here for you. So these are meant to be largely independent, right? So there's not going to be this overarching storyline, a learning progression that goes from each one. And really there was two motivations behind that. One is people just have limited time. So there's this prioritization of which learning targets you might want, and it might be different for different people. And then there might be this need to balance assessment types. And you'll see that some are labs, some are more knowledge-based. So with that remaining time that people have, you might pick and choose differently. And then I want to make the comment about the perceived time constraints, both what I've already mentioned with time, lots of people have said they're not going to have time for a full unit, or even just looking at what they need to do with unit 6 to finish that. And then will you add more? And then there's also the time constraint on the side of the Physics Council that really led to to be frank, is just led to departure from our design principles. And we'll be explicit about that. We'll try to let you know what resources are there and what's going on. And then just to be, we want to just explicitly acknowledge, and again, we'll call it out in the activities too, but some of these have not been tried with students. So we want that to be upfront, and that is different than a lot of the, essentially all the other materials that we present. So it's just the context and the situation that we're in that we felt that had to be acknowledged. Matt, I didn't know if there was anything I missed, or you just wanted to add.
No, I don't know. Maybe we skipped the slide about, is the next slide for chat versus question? Yeah. So I just wanted to also say, when you have questions, if you put them in the idea capture tool, that would be helpful for us to document where those questions are will live. That'll be in the parking lot there, and we'll answer that when either during the session, or more likely when you go into your choice breakout room. And then if you have questions for the participants that other participants might answer, put those into the chat, as it's harder for us to monitor there.
All right, so I will jump to the agenda then and just kind of try to give that overview. Again, just that introduction, the idea capture tool. Again, at the top is questions for us. And then similar to past ones, again, kind of overview of the prioritized remaining targets. And again, we're going to do that like 90-second overview, and then 3 minutes on each activity. And then we'll do a choice breakout where you can pick any of those activities and do a deeper dive. And just to say it a couple times, I'll just say the feedback, even from last meeting, please start with that student hat and then move to the teacher talk. So, and you're gonna, I mean, there's a lot going on. So there's more than the time we have. There's need for both of those. So, but please do try starting with the student hat. And then we'll come back in that last few minutes and really want to give a little bit of time for reflection. And that also is helpful for us, but also just to honor that time, to give you a little processing time, and then put both questions in the parking lot and verbal, and then adjourn at 5 o'clock. And good, so I'll maybe use this to transition to, here's the overview. You'll find it under unit 7. That just seemed like, again, I want to say this is not unit 7, but that just seemed like the natural place to house it, where people would go to look. And again, so the overview, I would say that, feedback's gonna be really key on these. for instance, I will go ahead and dive in a little bit. So activities. So one of an important activity that does live in Unit 7 is this performance expectation around explanations of the Big Bang. So one overarching comment though to say is about Unit 7, more that would be not in the distance learning model, but important to set that up for when we are back in person is, should Unit 7 have a strong storyline that really makes it fit together when people are having trouble getting to it, or something that we've piloted it and tried out in smaller pieces is, should that one have like 2 or 3 day chunks where if you have 2 days before winter break and you don't want to start the new unit, or you're going to be, one thought is to have it be, if you knew you're going to be absent 2 days, to have it be closer to asynchronous lesson. So this first one is close to that. It was really reduced. I mean, one of the things that we said that hurt me as an educator is that we really cut everything to be all business. Like this was not, lots of these, I want you to think of it as launching points. There's more you could go with than what we put there. But with the tension that we felt all of them needed to be just 2 or 3 days, which means that, I mean, that performance expectation could be a semester long course. And so that's it. So I'm going to try to be a little quicker with the remaining ones. But that first one is around constructing an explanation for the Big Bang. And that is more towards the asynchronous. We'll show that in the 3-minute version of it. And then we have the use mathematical or computational representations to predict the motion of orbiting objects. In the evidence statements, it really does talk about energy and Kepler's laws. But again, that's one that's utilizing that. And then there is that performance expectation. They really do want students to be aware of the inverse square law and how that comes up in both Newton's universal law of gravity and Coulomb's law of electric force due to electrical interaction. And then the ones that we missed in Unit 4, Newton's laws, really, for us engineering a shoe, because the emphasis wasn't necessarily on Newton's laws, but there is the performance expectation around the second law of motion. So that one, is obviously a big one for a physics course. And again, I'll say taking it down to 3 days and a little bit out of context does strip it of some of the context and the power, but it is one that I think a lot of people want to cover, and we wanted to provide resources for it. And then also that last one, the momentum, really conservation of momentum and impulse. So just trying to kind of say everything that's there, and now we'll just circle right back and kind of more on the 3-minute range, and I'll turn it over to Matt to talk about these first two.
Yeah, so starting with the first one there, what is the evidence for the Big Bang? This was a activity that was made by a Portland Metro STEM Partnership Council member, Scott Barentine, and he's created it and used for his students as like a alternative project during the year. And just wanted to say with this and with all of the lessons that we're providing, we always hope for feedback on these. So with this one, this has been reduced a lot from the original intent of it. And Bradford, if you could click on the the formative there. It's been reduced to a Go formative. And really the idea is to construct an overall explanation for the origin of the universe. And we're giving lots of evidence behind that to do that. Scott also made this these slideshows that are associated with that. And the slideshows kind of follow by giving some of the evidence that students couldn't come up with, for example, on cosmic background radiation and other things that are providing those resources to students to be able to watch, and then giving them opportunities in the Go Formative to reflect on. This activity was designed, and many of these activities were designed to be synchronous, that students really do need feedback on this. This is all very new information to them. And so while a Go Formative, students can kind of work at their own pace, but it also allows teacher feedback and allows that opportunity for that. So really, we think for it to be successful, there needs to be that give and take of synchronous time and student work time. Then with the second target on the agenda there is related to around orbital motion and making some predictions about orbital motion. Because energy this year in distance learning was taken off a little bit because of our work, we cut our more traditional energy unit and tied more of it into Unit 6. We wanted another opportunity to come back to energy bar charts here. So Bradford, if you could go into, that tab there. So we did start with this idea of the energy skate park. So when you look at the full scale activity, it starts with like a zoom out of orbital motion. And then we want to get a sense of energy with energy bar charts if they haven't been done with your students. This is a new Desmos that we made to allow students to get some instant feedback about energy conservation. And so we zoom in on the PhET energy skate park, where they're looking at the interplay between gravitational kinetic energy and gravitational energy and kinetic energy as it's moving back and forth. And this idea can be then transferred to orbital motion. So we're starting something more basic, and then we're moving into orbital motion. So we use this PhET for orbital motion. Students will interact with it in several ways. They'll make stable orbits around the Earth there with the satellite. And then they'll start interacting with it a little bit more in terms of the energy that is associated with it. And Bradford, I think if you could go to slide 9 there. Actually, can you go back one slide first, and then, so they start with this idea of like dragging the dots where they think the largest gravitational potential energy is, and then the largest kinetic energy. And then they do something very similar to what they did with the energy skate park, where now they have on an orbital scale, we can use energy to really describe what's going on with the motion of the satellite as it is moving around the Earth in that elliptical orbit. So when it's at closest, it has the highest kinetic energy and lowest gravitational energy, and vice versa. And I think that's a pretty good synopsis of that. That leads really well into the next activity that Bradford's going to present.
Yeah, and if you end up doing these two in order, there's a lot of connection you could utilize. But again, this activity, to get it down to 2 days, it really was sort of all business in terms of introducing a data collection mechanism that is really data mining. So Halley's Comet, the only short period comet to be seen again and again and again by humans with the naked eye. So it has some historical significance, and the kind of the peak will just focus on, there's slides that help introduce that. And then students are going to be given a data set that's sort of overwhelming, right? Data mining is a very important part of modern day science. And to keep it really short, I'll just say the one example that I share with students that they get a kick out of is is a lot of the times with medicines, experimental trials, not related to COVID at all, but just other medicines, they oftentimes look during a trial and they look for Google searches. And the funny one is just, and maybe it's, I don't know, it's obviously a real issue, is that like people in medical trials won't tell them certain side effects. Like they just find them embarrassing, like if it makes your butt itch. And so they would do Google searches on this. And lots of times there's only like 150 people in this trial, and they search that medicine and butt itch or put in any other side effect. And then the doctors, they do this with a lot of them. And then they don't just say, oh, that's happening. Then they ask the doctors to ask the patient. And if the doctor brings it up and says, a lot of other patients are feeling this side effect, are you experiencing it? They're like, yes. I didn't want to bring it up, but oh my God, yes. And so there's this data mining. So that's just that quick example. They data mine a set, and I'll just jump right in. And so really this is meant to be like overwhelming. It's just a lot of numbers. There's big numbers. We just see this with the astronomy, right? And they're going into chemistry. So it is a good time to start bringing up and introducing that. But in any case, all they really need to do is figure out, how does distance affect the force of gravity? So really all they need is distance and the force of gravity. And when this is done with an Excel spreadsheet, we have them copy and paste it over into Desmos. But that's just one more step in the distance learning format that they're on. Now they're on a spreadsheet and they got to get back to Desmos. And it's not easy when you paste it into Desmos. It doesn't, it makes it generic like X2 and Y2. So we, in a sense, we imported the data for them. So that no big deal. You can lock that screen and you can check which columns they're circling to just kind of make sure people are on the same page. And then really it's just, back to our, this is that new pattern, inverse square. And so it's just, again, that mix, we do add a new pattern. And that's also kind of nice to end the year on, hey, we've been working with these 4 patterns and they cover a lot, but it's not everything. It's not even close to everything. So in any case, and then there's just a card sort. And I just want to show that it hopefully this is not hard hitting. And the big things from the evidence statements are understanding that inverse square really is different than the other ones. And so in any case, I'll just quick, I don't even know that this is, I might be close to the 3-minute mark. The A value is going to depend on, yep. And this might be you structuring a little bit of classroom discussion on it, but I just want to read this. Similar to blank pattern, doubling the input distance has a 4 times effect on the force of gravity. And this one, that's going to be the hardest one for them. We just want them to see it is kind of connected to quadratic, right? It does have that little 2. It's squared, but it's on the bottom. So it does have this like 4, squaring effect. Whoops. And then doubling the, let's see, similar to the blank pattern, doubling the input decreases the output force. So we do want them to see that, like inverse, when the input gets bigger, the output gets smaller. And then almost by a process of elimination, but also the force, here's our equation. Oh, that's supposed to say 3 cards. Oh, no, it's not, because that's, this is the inverse square law, and doubling the input makes the output times smaller. Yep, we want them to realize that's what's going on with the inverse square. And of course, the constant in the A value, almost by a process of elimination, but hopefully maybe there's some discussion somehow that they're like, of course, the strength of gravity depends on the mass of the objects, and then the strength of gravity, that's the gravitational constant, but we didn't feel the need to actually call out G. It's not in the evidence statements. And of course, launch point, if you want to, and you have that bandwidth and you have the time to give it. And of course, this could go farther. And a real fun one in our in-person is we then use this combined with the orbits activity to talk about dark matter. And I'll say this super quick because if I can get it 20 seconds. If you look at the orbits of stars inside of galaxies, of course, the mass that's inside of them, which should be related to the velocity they're going. And because there is missing mass, there's gravity that's keeping these stars in orbit, but it's not giving off any light. That was named, this missing mass was named dark matter, because it's matter because it's exerting a gravitational force on these stars, keeping them in these unexpectedly tight orbits around the center of the galaxy. It's not giving off any light. And so dark matter. So that's a real fun one. And of course, you could springboard to dark energy. That's not in the standards, but if you felt comfortable with it, I just want to say that this is a bare bones one so that it really fits in that 2-day time constraint. And then cycling, zooming back out. Oh, no. This is me also. So then, Newton's second law, probably the most, impactful equation in classical mechanics, a little bit hard to shrink it down to just a couple days. But we do, that was sort of the constraint that we had for these activities. And so again, you might be in a situation where you can add back some of those days. I'll just, maybe I'll start with the PhET. No surprise, in the distance learning format where we did go, PhET that is always part of an in-person learning experience with it. And of course that just allows them to take data, and we'll show, this is the resource that we selected just to show that it does have continuity with it. It is, this is just one page, right? So we want to get across that this is doable in just a couple days with these resources, but also know that there are some wraparound resources. Whoops, sorry, I went too far. Just right here that you can see, I want to put that there is a goal formative activity that again just allows that some of that check-in, kind of a pre-assessment almost. And then I wouldn't quite call this one a post-assessment, but it is checking on, are they comfortable with the terminology around it? The actual lab report itself, you could expand it to a conclusion if you wanted that, or another way of showing their understanding of the topics. And then I'll turn it over to Matt for this last one on momentum.
Yeah, the last one on momentum is really kind of a re-envisioned model of something that we've done in class for several years now, looking at momentum and looking at several different videos associated with it. And we envision this more as an interactive lecture. If you had a day or two that you wanted to insert in, there are some references to rockets, so envisioning some of that could be tied into space as well. And Bradford, could you click into that Go Formative activity? So if you're familiar with some of the things that we did in Unit 4 around momentum, we've focused it around this slow motion video of man getting hit in the face with a filled up soccer ball, and we basically track the momentum change through that. And as a good, I'd say, classical model of what momentum is, then we take that idea and expand on it and push it forward to some other situations. And finally, the last situation, if you scroll all the way down, is you missed it there. Is a rocket. So
that's a
essentially, sorry, is a rocket where they're looking at the momentum involved in a rocket, that conservation of momentum takes place, rocket's mass goes up and the fuel goes down, conserving momentum while still propelling the rocket. So that's a kind of a take on that. Bradford, if you go back to the calendar, you can see, I think if you refresh, it should be there in a second. If not, there is a link to some slides that are the kind of the native slides that we used. So yeah, the link to the past teacher slides that are associated with that. So if that's something that you're interested in, you could look at those teacher slides and use those to help you with that instruction. That is definitely one that is intended to be kind of an interactive lecture that you're watching videos together with class. They're thinking through, getting feedback, showing student work, and trying to use GoFormative in that aspect where we get this live feedback and we're able to interact with students in that way and give them feedback there.
And I'll expand that, and remember that the in-person resources are a resource for all of these. You know, you would go back and hunt for which learning target they're from. So hopefully those are known to you as a resource to supplement. And then be in a situation where they are going to be more asynchronous. And I just want to say that and that just needs a little bit of support. And that when we say synchronous, it doesn't necessarily mean, I mean, optimally it would be like the closer the feedback is, the more helpful and actionable that might keep a student. But this could be, you know, if you do need to, you're in a situation where you're only meeting twice a week or something, you might be in a situation where if you can, they need feedback, it doesn't necessarily have to be verbal feedback. So, you know, within GoFormative, you can have that back and forth as well. Okay, so zooming even further out just to our overall agenda, I think we're doing good on pretty much right on time. And, you know, we were guessing that people from feedback we got last time, and then just kind of the situations that we're hearing around the state, is that, you know, lots of people might have just time for one of these or two. So, but people might want to do different ones. We really, you know, space is kind of just a different way, you know, it grabs different students that some of the other topics in the course might not have. So that one, but of course, you know, acceleration equals force over mass, so important. So we really thought we just didn't want to pick for you which activity you want to go on. So in a minute, especially if you're familiar with Zoom, but if you're not, we'll fly. And actually I did learn that you have to have the newer Zoom to have this pop up. So we'll handle it for anyone that doesn't see it, but shortly there's going to be a window that pops up, and you are going to have to go onto the room, and onto the right, it'll say join when you hover over it with a mouse. And so we're thinking that we want to keep the rooms just to like 3 to 4, just to give people a chance to process. So some rooms we anticipated, you know, like Newton's second law might have more than 3 people that want to look at it, or orbital motion, or evidence for the Big Bang. So we made multiple rooms of it. So once a room has 3 people, start up the next room. And if you end up with a room where you're only by yourself, we're going to be monitoring that quick, and we might move you back into a room that has some people so that you don't get stranded there. So just want to let you know with that. Before we send you off, we always want questions, and I didn't check this time, but we see a couple questions here right now. We'll probably try to answer those right now. And then if you call us into a room, happy to join you. And then we'll just be here though. So as you discuss this, please do start with that student hat. We do get that feedback. We know that you also need teacher talk too. So just say that the feedback from participants has been start with the student hat on and look, but just as questions come up, put them in right here, and we'll try to answer them kind of in real time even. So kind of maybe you want to have this portion pulled up if you have multiple tabs open, this and the activity, and then we'll try to get you feedback that you are asking. I think we're getting close, and I'll just turn it back to Matt to just check in on if I missed anything.
Yeah, so with that, I'm going to open up rooms here in just a moment. Decide which of the resources that you want to look at. And I labeled on my Zoom, I had to expand the window, and I'll open it right now. You should be able to see, I think if you down at the bottom of Zoom, I believe it should say breakout rooms. Are you seeing that, Bradford? I can't see it since I'm the host.
I do not see it.
Let's see, maybe under.
Oh, maybe I'm going to stop screen sharing for this moment.
Okay.
Oh, and I will say also the other feedback that we got that seemed to work well for people is if one person's willing to share their screen inside, and I was just trying to check that we've enabled them to be able to do that. is if you share your screen, one person, then it's, yeah, I guess it's not a joke, it's literal that you would be on the same page then. So that way it just kind of ensures that you're talking about one thing and someone else is talking about another and you don't realize it. So if someone could kind of agree to do that. I'm going to click on breakout. Oh, I see it. I had to click on breakout rooms. No, I did need to click on breakout rooms and now I see it.
Yeah, so it's down at it should be down at the bottom there where it says breakout rooms. Next to it, I see people are kind of choosing to join in there. Next to those rooms, there is a number. You will have to click the blue number that says join.
It'll
And
turn to join once you hover over it.
it'll say join once you hover over it. And you can find the room that you want to go to and join another person who might be there. All right, well, welcome back everyone. Sorry about that whiplash if you were in the middle of a conversation there. Just wanted to say any additional questions can still go into the top of the idea capture tool. We answered 2 of those there while you were in breakout rooms. We do ask you to go to complete numbers 5 and 6 in the idea capture tool, just using that space to think about the level of scaffolding that you might, your students might need. And then just what was a 1-sentence summary or takeaway from the webinar today. So we'll give you just a little bit of time to do that, answering that on yours. And we'll kind of come back together for some live questions here in a minute or 2. Give you about 1 more minute and then just see what live questions come up before we adjourn. All right, yeah, we'd like to just open this up to questions. One thing that I saw, I was looking through the idea capture tool, was that a number of people were just noting that the materials provided here were really like kind of pick and choose for you and your students. I would not claim that this is our Unit 7. It's really those prioritized learning targets that are there. And definitely in person is a lot more in depth there. So do we want to open it up to other questions that people might have before we adjourn here?
Great. Well, then I think we'll stay on, but we just do bring some closure. We'll do a countdown, 3, 2, 1. But sometimes we just, just there's a case where people want to ask a question in the more close setting. So I think we'll move to that. But if you're good, thank you for coming. And if you're willing to just unmute and say bye, it's really just always nice to hear some voices. So 3, 2, 1. Bye.
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 Thank you very much.
Bye. Thank you.
Thank you.
Yeah, you're welcome.
Thank you. Appreciate it.
Well, thanks, Bradford.